All right, so the next two exercises require us to sort of look at this definition formally and then a little more informally. And just as a heads up, I typically like the idea of looking at this sort of informal definition of independent more than the formal definition. But let's look at the first question. So we have our events. A was summing to 7, B was doubles, C was summing to 10. Our first question is whether or not these pairs of events are disjoint. So let's just look at each pair. We have A and B as a pair, B and C as a pair, and then we have A and C. So disjoint means that they have no outcomes in common, right? So A summing to 7 and doubles. Is it possible to have a doubles that sums to 7? No, because if they're doubles, they're going to sum to an even number, which means they cannot be a 7. So these are disjoint. Okay. Oh gosh, I was not meaning to move that. I meant to erase what I had written so we can move on to the next pair. Sorry for that weird ass wiggle. All right, so then looking at, B versus C. All right, doubles and summing to 10. Is there any overlap? In fact, 5, 5 exists in the overlap, right? That is a thing that would fall into the doubles category and then fall into the sum to 10 category. So B and C are not disjoint. They would be joint. All right, our last one is looking at A and C. So now we're saying, can they sum to 7? Can they sum to 10? Is it possible for a pair of dice to do both? And obviously no, because if it sums to 7, it doesn't sum up to 10. So these are also disjoint. So those are our two pairs that are disjoint, whereas B and C do have some overlap, some shared outcomes in common. So independent is a little more challenging, right? So we're going to look at each of those pairs. And again, we're going to use more of a formal definition here. And then we'll talk about how we could have maybe stepped around this a little quicker. So A and B, summing to 7 and doubles. Well, let's just use the definition. So our definition here is that the probability of A given B, and so I'm just using the definition that was right above this guy, is equal to the probability of A. So the probability of A summing to 7, remember there was 6 out of the 36 ways for that to happen. If we know that B has happened, that's what the second one says, right? We know B has happened, so we're in this land. 1, 1, 2, 2, 3, 3, all the way to 6, 6. We know we're here. What is the probability of A? Well, now there's only 6 events because we're in B. And, the probability of A is 0 because there's no way that these two things can overlap. So A and B are not independent. In fact, remember we said this, I don't know that we've talked about it, but the two events themselves, these two special cases, disjoint and independent, they can't occur together. So you're going to see the exact same thing with A and C. You'll do the exact same work. You'd say, okay, there's so many different ways. It can't happen either. As soon as they're disjoint, whenever you have the given, you're going to go to a 0 when you know B. So neither of those are independent. So the only one we really need to check is B and C, the one that failed to be disjoint. All right, so we're going to use that same test that we just saw. Probability of B given C is equal to the probability of B. Essentially, knowing C hasn't given me any new information about whether or not B will happen. So B, this was doubles. There were 6 ways out of 36 for this to happen. Let me go ahead and write down my event space for C. So C was 4, 6, 5, 5, 6, 4. Those are all the ways that you can sum to 10. So now we only have a sample space of 3. And how many ways can we end up getting out the B that we wanted, that we were interested in? Only one of those 3. So is 1 out of 3 the same as 6 out of 36? The answer is no, because 6 out of 36 is 1 and 6. So these are not independent as well. So none are independent. That's our answer to the second question. So now they've given us 2 new events. D is the first dice rolled, shows a 3, and E is the second one, shows a 4. So I want you guys to take a moment, Try this one on your own. This is something more similar to what I put on a test. See if you get this correct. All right, so hopefully you paused. So first die I rolled shows a 3. If I was going to write out the event space for D, this would be 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, and 3, 6, right? Those are all the different ways for that to happen. And E would be obviously 1, 4, 2, 4, yada, yada, yada. I'm going to get lazy here. So the question is there anything in common, right? Because that's what gives us disjoint. And we can see here, I didn't keep going, but 3, 4 would have also been an E. So 3, 4, there is an overlap. There is something in common. So I can go ahead and get rid of all the answer choices that say they don't have anything in common. Get rid of all the disjoint answer choices. And now the question comes down to that dependent test. So it doesn't matter which order I do these in. Since I wrote out all of D, I'm actually going to go the opposite direction that I did on the previous question. Again, the idea of independence is what I have on the back there. It doesn't matter. Knowing D, knowing that we're in this place doesn't change anything. So this should still be the probability of E. So E would have been 6 out of 36, right? If I'd kept going, there would have been 6 different things written there. E out of the D situation, well, that is 3 out of 4. So that is, or 3, 4. That one event out of all 6 in D. In fact, these are equal. So we have our first example with the dice of independent events. And obviously you could have done this one by common sense. One roll of the dice does not affect the next. And of course I can roll a 3 and then roll a 4. But I just wanted to show you how to more formally prove or show these things if you wanted to.